One common SAS programming task is creating a SAS dataset. You can create a SAS dataset from several types of data. In this lesson, you learn to create a SAS dataset from an existing SAS dataset. First, you learn to create an exact copy of a SAS dataset. Then, you learn how to use the data step to manipulate the data so that your new SAS dataset is different from the original. Here's what you learn in this lesson. Orion.sales is a SAS dataset that contains information about Orion Star sales employees from Australia and from the United States. Suppose you need to use the data in Orion.sales to create a new SAS dataset that contains a subset of this data. First, you need to create a temporary copy of Orion.sales and name the new SAS dataset work.subset1. In order to create a new SAS dataset, you start with an existing data source known as input data. Your input data might be a SAS dataset. Your input data could also be a Microsoft Excel worksheet or a raw data file. You can use a data step to read input data in any of these three formats and to create a new SAS dataset. The new SAS dataset is the output from the data step. In the example shown here, the input data is a SAS dataset. Now, answer this question. You use a data step to create a new SAS dataset. The syntax for a data step is shown here. In its most basic form, a data step contains a data statement, a set statement, and a run statement. The data statement names the new SAS dataset, which can be temporary or permanent. The set statement names the existing SAS dataset that you want to read in as input data. The run statement marks the end of the step. A basic data step that includes these three statements creates a new SAS dataset that is an exact copy of the input SAS dataset. In a real setting, you probably wouldn't use a simple data step like this one to copy a dataset. There are other ways of copying datasets that are more efficient. But this simple data step is a good building block. As you'll see in the rest of this lesson, you can add more statements to a basic data step in order to do much more than just copying datasets. Remember that in order to reference a permanent library in the data statement or the set statement, the libref must be already assigned. You use a libname statement to assign a libref. You can use different librefs in the data and set statements within one data step as long as both librefs have been previously assigned. Here's a question. Does the data step shown here create a temporary or permanent SAS dataset? It creates a temporary dataset because it references the temporary library, work. To review information about the libname statement, click Review. Try answering this question. In order to assign a name to a dataset in the data statement, you need to know the rules for naming SAS datasets. SAS dataset names can be 1 to 32 characters long. The name must start with a letter or underscore and can continue with any combination of numbers, letters, or underscores. SAS dataset names are not case sensitive. These are some valid SAS dataset names.
Now that you've seen the syntax and rules for reading and creating SAS datasets in the data step, let's look at an example in SAS of using a data step to create a new data set from an existing data set. Suppose you want to create a temporary SAS dataset named work.subset1 from the input dataset orion.sales. You start with the data statement and specify the new SAS dataset name work.subset1. Then you use a set statement to specify the input data, orion.sales. You end the step with a run statement. Submit the program and check the log. Notice the error message about the Orion live name. An error message like this indicates that you need to add a live name statement before the data step to assign the Orion live ref. If there were other live refs used in the step, you would need to make sure they had been assigned as well. For now, add a live name statement to define the Orion live ref. Then, submit the program. If you check the log, you can see that the data set was created successfully with 165 observations and 9 variables. Another way to verify that your data set was created correctly is to submit a proc print step and view the listing output. You can see that the data set contains 9 variables, and if you scroll down, you can see that there are 165 observations included.
Answer this question. Now, try practicing in your You've seen that when you submit a data step, SAS processes the data step and then creates a new SAS data set. Let's take a look behind the scenes so you can understand how that happens. SAS processes the data step in 2 phases, the compilation phase and the execution phase. During the compilation phase, SAS scans each statement for syntax errors. Most syntax errors prevent further processing of the data step. When the compilation phase is complete, SAS creates the descriptor portion of the new dataset. Remember, the descriptor portion contains information such as the dataset name and the names of all the dataset's variables. If the data step compiles successfully, then the execution phase begins. During the execution phase, the data step reads and processes the input data and fills in the data portion of the output data set. The data step executes once for each record in the input file, unless otherwise directed. Answer this question. Let's take a closer look at the compilation phase. You know that SAS creates the descriptor portion of the new data set at the end of the compilation phase. But what happens during that phase? First, SAS creates the program data vector, or PDV. The PDV is an area of memory where SAS builds a dataset, one observation at a time. The PDV contains 2 automatic variables that can be used for processing, but that are not written to the dataset as part of an observation. _in_ is the iteration number of the data step. _error_ signals the occurrence of an error that is caused by the data during execution. The default value is 0, which means there is no error. When one or more errors occur, the value is set to 1. During the compilation phase, SAS also scans each statement in the data step, looking for syntax errors such as missing or misspelled keywords, invalid variable names, missing or invalid punctuation, or invalid options. When the set statement is compiled, a slot is added to the program data vector for each variable in the input dataset. The input dataset supplies the variable names as well as attributes such as type and length. In the example shown here, Orion.sales contains more variables than can be shown on the screen. Don't let that confuse you. The set statement reads all of the variables from the input dataset and adds a slot to the PDV for each of them. At the bottom of the data step, the compilation phase is complete, and the descriptor portion of the new SAS dataset is created. At this point, the data step is ready for execution. Now, let's take a look at what happens in the execution phase when SAS creates the data portion of the new dataset. Remember, the data portion contains the data values. In the first iteration of the data step, SAS reads an observation from the input dataset, stores the values in the program data vector, and then writes those values to the new dataset as an observation. Remember, _in_ and _error_ are not included in the new SAS dataset. Then, control returns to the top of the data step and the next iteration begins. SAS retains the values of variables that were read from a SAS dataset in the PDV and increments the value of _in_ by 1. As the set statement executes, SAS writes the values from the second observation to the PDV. At the end of the data step, SAS writes the second observation to the new SAS dataset. This process continues until all of the observations are read. The data step executes once for each observation in the input data, unless otherwise directed by additional statements. So, at the end of the execution phase for a basic data step like the one shown here, the new SAS dataset work.subset1 contains all of the same data and descriptor information that was in the input dataset Orion.sales. Now, try answering this question. Remember that Orion.sales contains information about Orion Star sales employees from Australia and from the United States. You've seen how to create a new SAS dataset that is an exact copy of Orion.sales. But suppose you want your new dataset, work.subset1, to contain only information about Orion Star employees who are from Australia and who have the word rep in their job titles. Instead of creating an exact copy of Orion.sales, you need to subset the observations in the input dataset as you create your output dataset. By default, a set statement reads all of the observations in a SAS dataset and writes them to the new SAS dataset. But you can control which observations are written to the output dataset by adding a where statement to your data step. The where statement follows the set statement within a data step, and there can be only one where statement in a step. The syntax of a where statement is shown here. The where expression specifies a condition for selecting observations and can be any valid SAS expression. Remember, an expression is a sequence of operands and operators that form a set of instructions. There are several rules you must follow for a where expression. You can include variables, constants, or both in your where expression. Variables in the where expression must be included in the input dataset. Character constants must be enclosed in quotation marks. You do not enclose numeric constants in quotation marks. You can use comparison, arithmetic, or logical operators in a where expression. There are also several special where operators that can only be used in where statements. Let's look at each of these types of operators in more detail. The comparison operators, which are shown here, compare a variable with a constant or another variable. You can use either the symbol or the mnemonic in your code. Look over these examples of comparison operators used in where statements. Remember that character operands must be enclosed in quotation marks. You do not enclose numeric operands in quotation marks. The arithmetic operators, which are shown here, indicate that an arithmetic calculation is performed. Look at these examples of arithmetic operators used in where statements. Logical operators combine or modify expressions. You can use either the symbol or the mnemonic in your code. Here, you can see the logical operators that are available and several examples of where statements that use these operators. In addition to the general categories of operators that you've seen, there are several special operators that can only be used in a where statement. Let's look more closely at these special where operators. The between and operator selects observations in which the value of a variable falls within an inclusive range of values. For example, the where statement shown here selects observations in which the value of salary is between 50,000 and 100,000. You could write an equivalent statement without using the between and operator, as shown here. You could use the between and operator along with the not operator to select values outside of the specified range, as shown here. The is null and is missing operators select observations in which the value of a variable is missing. These operators can be used for both character and numeric variables. For example, the where statements shown here both select observations in which the value of employee ID is missing. Here's a question. Can you think of another operator you could use to select observations with the missing value? You could use the equals operator, as long as you knew whether the variable was numeric or character. The contains operator selects observations that include the specified substring. The position of the substring within the variable's value does not matter. For example, the where statements shown here would select observations in which the value for job title was sales and marketing, internet sales, or salesman. The contains operator is case sensitive, so you must specify the substring in the exact case that you want it to match. The like operator selects observations by comparing character values to specified patterns. There are two special characters available for specifying a pattern. The percent sign replaces any number of characters. The underscore replaces one character. Consecutive underscores can be specified. A percent sign and an underscore can be specified in the same pattern. For example, the where statement shown here selects observations in which the value of name ends in a capital N, which is preceded by any number of characters. This where statement selects observations in which the value of name begins with a capital T, followed by a single character, followed by a capital M, followed by any number of characters. For more information on the like operator, click Details.
Now that you've learned about where statements and seen the many operators that are available, let's take a look at subsetting observations in a data step in SAS. Start with the data step that you used to create a temporary copy of Orion.sales. This time, suppose you want to change the data step so that work.subset1 contains only those employees who are from Australia and who have the word rep in their job title. You can use a where statement to select the employees that you want to include. To select employees from Australia, you need to look for values of AU for the variable country. To find employees with the word rep in their job titles, you can use the values for the job title variable. You add the where statement after the set statement. This where statement selects only those observations where the variable country has a value of AU and where the value of job title contains the word rep. If either of those expressions is false, the observation will not be included in the output data set. Here's a question. Can you think of a way to write this where statement using different operators or symbols? You could write it like this: where country EQ AU and job title like percent rep percent. If you submit the step, you can see in the log that it ran without errors and that the new data set was created with 61 observations. Notice that all of the observations have AU as the value for country and have rep somewhere in their value for job title.
Now, answer some questions about the Now, try using the data. You've seen how to modify a data step so that the output dataset contains a subset of the observations in the input dataset. Now, suppose you need to create a new SAS dataset named work.subset1 that contains only the employees from Australia who have the word rep in their job title and only includes some of the variables from Orion.sales. That is, you want your output dataset to contain a subset of the variables in the input dataset as well as a subset of the observations in the input dataset. As you've seen, the set statement reads all of the variables from the input dataset and writes them to the output dataset. You can exclude variables from your output dataset by using a drop statement or a keep statement. You can see the syntax for the drop and keep statements here. The drop statement specifies a list of variables to omit from the output dataset, and all other variables in the input dataset are included. The keep statement specifies a list of variables to include in the output dataset, and all other variables in the input dataset are excluded. You might want to use the keep statement instead of the drop statement if the number of variables to keep is significantly smaller than the number to drop. The keep statement can also be advantageous because it enables you to see what variables are included in the dataset by viewing only the data step.
Okay, let's look at subsetting variables in the data step in SAS. You already have a data step that subsets our input data to make sure that the output SAS dataset includes only those observations that fit our criteria. Employees from Australia who have rep in their job title. Now let's look at how to further edit this data step so that the output SAS dataset includes only those variables that you want to see: first name, last name, salary, job title, and hire date. Remember, you could use either a keep statement or a drop statement to subset the variables. Because you have the list of variable names that we want to keep, let's use a keep statement. You add the keep statement after the where statement and list the variables that you want to keep. Notice that this program includes a proc print step, so when you submit it, you can see a listing of the output SAS dataset work.subset1. Just as we expected, it now contains only 5 variables.
Answer this question. Now, try practicing. You've seen how to subset both observations and variables in order to create a customized output dataset. Now, suppose you need to create work.subset1 so that it includes permanent labels for several of the variables. You need to add labels to the descriptor portion of the new dataset. Sometimes you might want to change the appearance of a variable in order to make your reports more readable. You might want to use a more descriptive variable name than what is stored in the SAS dataset, or you might want to format the value of a variable differently. You can use labels and formats to make these types of changes. A label changes the appearance of the variable name, and a format changes the appearance of the variable value. Labels and formats affect the way that variables look when you display them in reports, but they do not affect the way variables are stored in the SAS dataset. Remember that the descriptor portion of a SAS dataset stores variable attributes, including the name, type, and length of the variable. You can also store labels and formats in the descriptor portion in order to permanently associate them with variables. You use the label statement in a data step to permanently associate a descriptive label with a variable in the descriptor portion of a SAS dataset. Here is the syntax for the label statement. You use the keyword label, followed by the variable, an equal sign, and the descriptive label that you want to apply to the variable. You enclose the label in quotation marks. You can specify labels for multiple variables in one label statement, or you can use a separate label statement for each variable. A label can be up to 256 characters long. After a label has been permanently associated with a variable, you can choose whether you want the label or the variable name to appear in proc print reports. If you want to see the descriptive label in your report, you add a label option to your proc print statement. If you want to see the variable name, you omit the label option. Now, answer this question.
Let's look at adding permanent labels to the descriptor portion of a SAS dataset in SAS. Here's the program to create a temporary SAS dataset that includes a subset of observations and variables from the input SAS dataset, and then prints a listing of the new SAS dataset. You need to edit this program in order to add permanent labels to the descriptor portion of work.subset1. Suppose you want to add the label sales title to the job title variable, and add the label date hired to the hire date variable. You use a label statement to add these labels. Remember that you need to enclose the descriptive labels in quotation marks. Before you submit the program, let's add a proc contents step so that you can view the descriptor portion of work.subset1. Also, if you want the listing output to include the descriptive labels instead of the variable names, you need to add a label option to the proc print step. Now let's submit the program and examine the output. You can see in the proc contents output that the labels have been added to the descriptor portion of the work.subset1 dataset. In the proc print output, notice that sales title and date hired have replaced their variable names as headings.
Adding formats is similar to adding labels. You use the format statement in the data step to permanently associate a SAS format with a variable in the descriptor portion of a SAS dataset. Here's the syntax for the format statement. You use the keyword format, followed by the variable, and the SAS format that you want to apply to the variable. You can use a separate format statement for each variable, or you can format several variables using either the same format or different formats in a single format statement. All SAS formats use the same form, as shown here. The $sign indicates a character format and precedes the name of the SAS format or user-defined format. Then, you specify the total format width, including decimal places and special characters. The period is a required delimiter. Finally, you specify the number of decimal places in numeric formats. Let's look at a few general examples. This table shows the general form for several common SAS formats. Now let's look at a few specific examples of SAS formats. This table shows several specific SAS formats and their effect on stored values. If you do not specify a format width that is large enough to accommodate a numeric value, the displayed value is automatically adjusted to fit into the width. Character values are truncated if they do not fit in the specified width. In the first example, you can see that the stored value, programming, is displayed as prog because the assigned format only has a width of 4. The other examples shown here are numeric values. You can see that these values are rounded off instead of being simply truncated. Answer this question. You might have noticed that in the proc print reports that you have seen for the work.subset1 dataset in this lesson, the values for hire date do not look like recognizable dates. That's because of the way that SAS stores date values. SAS date values are a special category of numeric value. SAS stores date values as the number of days between January 1st, 1960 and a specific date. In order to make SAS date values appear as meaningful date values in your reports, you must apply a SAS date format to the SAS date values. This table lists several common SAS date formats and shows how each one affects a stored SAS date value. When you're ready, click Continue to see more common SAS date formats and examples. This table lists additional common SAS date formats and shows how each one affects a stored SAS date value. The SAS National Language Support date formats convert SAS date values to a locale-sensitive date string. To learn more about the NLS features that SAS contains, click Details.
Now that you've seen some of the formats that are available, let's take a look at adding permanent formats to the descriptor portion of a SAS dataset in SAS. Remember, this program created a temporary SAS dataset named work.subset1 that contained a subset of the observations and variables from the input SAS dataset and included descriptive labels for 2 of the variables. Now let's add formats to a couple of the variables. Suppose you want to format the salary variable and the hire date variable to make the report more readable. So, you add a format statement after the label statement. For salary, use the (8) format. And for hire date, use the DDMMYY10 format. The order of the format and label statements is not important. Now you can submit the program. The proc contents output shows that the formats have been added to the descriptor portion of work.subset1. The proc print output shows that the salary values have been formatted. Remember that the hire date values are now under the descriptive label date hired, and you can see that they have been formatted also.
Answer this question.